Okay, let's start. Today is our fifth lucid. Today we'll speak about oligopoly, about Cournot competition and Bertrand competition. Our first problem is about oligopoly in Cournot. First one. Let's start. So, what we have? We have inverse market demand in the task Q capital 1 minus 1. And in this market we have n small firms. We'll say that they are S, index S, with constant marginal costs equal to CS. Marginal costs of each small firm is constant and equal to CS less than 1. Then we have K large firms. We'll say that they are L large, and also marginal cost for each large firm are constant and equal to CL that is less than CS. So it is cheaper to produce for large firms. Yes? What is next? Our task, point A, is to find Nash equilibrium when each firm independently and at the same time, simultaneously, set quantities in the market. Nash equilibrium if each firm set quantities. So, this is Cournot competition in oligopoly. What we will say? Let's say that Q E S is the quantity that will be chosen by one small firm. Each firm for E equal from 1 to n. This was small. And let's say that Q EL is same but for large firms. For E from 1 to K. This for large. Okay. What each firm does? Each firm independently maximizes her profit. Yes? So now we'll write down the profit for firm I and maximize it. And what means that simultaneously and independently? This one firm maximizes her profit by only her quantity, and and quantities which are chosen by other firms, she is taken as given. Yes? So what will we write? For example, for small firm, the profit of small firm, of one I small firm, is what? Total revenue minus total costs. We know that total revenue is price multiplied by quantity. That is solved by this firm. But we have oligopoly. We don't have perfect competition, so price is not constant. Price is given as inverse demand, maximum willingness to pay in the market for the good. So this will be price 1 minus total sales in the market. Total sales is the sum of all quantities that are sold by all firms. So we should write that this is the sum from I equal to 1 to n, the sum of quantities of all small firms, and minus the sum of quantities which are sold by large firms. This is price multiplied by quantity that is sold by, by our firm. This is her revenue minus total costs. We know that marginal costs are constant, that's why they are equal to average costs. So total costs are simple, are equal to CS multiplied by the quantity. And this we should maximize by quantity of firm I small greater or equal than 0. So let's write down first the condition. What we should do? We should take the first derivative and equalize this to 0, and the derivative by quantity of this actual firm. Yes? So let's write down. Profit prime derivative by QES is equal to what? Our firm take as given all the quantities of all other firms. She cannot control it. Yes, she can control only her quantity. So what we will write down in the derivative? Here everything is constant here except quantity of firm I. Yes, and this, her quantity is in this sum. Yes. So when we take the derivative, we should write 1 minus the sum from I equal to 1 to n, but how to write? Let's write that here are not I in sums, but j. Here j, here j. Only in sums. So we can write like this. From j equal to 1 to n, and j is not equal to I. All other quantities except our firm's quantity. For g s minus, here are all constants for large firms, sum from j is equal to 1 to k, quantity ja, and here in profit there will be quantity of firm I small square. Yes, and then when we take the derivative, it should be minus 2 quantities of firm I small and minus CS. And this first derivative should be equal to 0 for interior solution. For quantity of firm I is greater than 0. Yes? So, from here, what we should find? We should find the best reaction of our firm on strategies of other firms. So we will write down best response function of our small firm. Best response function of firm I small is what? Quantity of firm I small is equal to, from here, is equal to 1 minus sum from j equal to 1 to n, gs, and j is not equal to 1 minus the sum j is equal to 1 to k, gl minus cs divided by 2. So I take from here, yes? And this is true only if the quantity of our firm is greater or equal to 0. So this should be greater or equal than 0. It is when all other firms produce less than 1 minus CS from here. When 1 minus CS greater or equal than all these sums. Sum from j equal to 1. J is not equal to I to n who g is plus sum from j equal to 1 to k who g l. All our other firms produce less than 1 minus marginal costs of our firm. And our firm will produce 0 if this is not true. Otherwise, so we wrote down best response function of our small firm. And what we can write? We can write that it is true also for all large firms. So for simplicity, we will say similarly, write down profit of large firm, of one large firm, and then write down the answer. And that's all. Because the only difference will be in these indexes, and that's all. Let's write down similarly. Profit of one large firm is equal to price 1 minus sum from g equal to 1 to n, who g is minus sum from g equal to 1 to k, who g k minus, let's write down the costs, minus c l, marginal costs of large firms, multiplied all these brackets, multiplied by quantity of our large firm, one large firm, and this we should maximize by quantity of this firm greater or equal than 0. And other quantities she is taken as given. Then, and we can write down best response function. Best response of firm I large is what? Quantity of firm I large is equal to same, but there is we will change a little bit. 1 minus sum of quantities of all small firms from g equal to 1 to n, which is minus sum from g equal to 1, but g is not equal to I, is not equal to our firm, to k who g large minus costs, marginal cost of large firm divided by 2, and this is true only if all other firms produce less than 1 minus CL. 1 minus CL greater or equal than this all firms. Sum from g equal to 1 to n, who g is plus sum from g equal to 1, and g is not equal to I to k who g l, and she will produce 0 otherwise. So, guys, please ask questions. Is it clear? Do you see everything?
Yes, and why we don't check shutdown?
Shutdown? In oligopolies, you can. It's not obligatory for you to check shutdown condition, because we know that it's oligopoly, and we will produce produce and then have profit greater than 0. Yes, but we don't have fixed costs, we have only variable costs. And that's why we should compare profit from our quantity with profit from 0. Profit from 0 is 0. And we know that if it is oligopoly, we will have positive profit, so shutdown is very simple. Yes, so we don't check it. And second order condition is very hard to check, so it's not obligatory also for you to check second order condition. In such tasks, you should only do first order condition, and that's all. So let's move on. So now we have best responses of all small firms. This is true for each small firm from, for I from 1 to n, and this is true for each large firm, for I from 1 to k. And what is equilibrium? Equilibrium is the situation when each firm independently from each other, they do not want to change their strategies. And strategy for us now is to set quantity. So, what we should do? Let's consider only symmetric Nash equilibrium. Why? Because we know that all small firms, they are identical. Yes, same costs. Yes, same good. And all large firms also identical. So we can say that let's consider only symmetric Nash equilibrium. There can be other equilibrium, but we will not check them. Symmetric Nash equilibrium, such that each small firm produce, for example, the same quantity, yes, and each large firm produce QL, same quantity, and that's why it will be easy to write down all these conditions. These sums will be, for example, here, this sum will be only K multiplied by QL, and that's all. Yes, because they produce the same quantity, each firm in each group. Let's write down interior solution. When each firm produces something greater than 0, interior. For interior solution, we should take only these parts, here and here, not 0, not 0. So it will be quantity of small firm is equal to 1 minus this sum. How much firms is there? Who can answer? How many firms here in this sum? From G is equal to 1 to n, and G is not equal to I. All firms except our firm. So there will be n minus 1 minus our firm. N minus 1 multiplied by QS minus here K firms that produce the same quantity. K QL minus CS divided by 2. And at the same time, optimal reaction should be from large firms, from each large firm. Quantity of large firm is equal to 1 minus here the sum, same quantities, and here n firms, n multiplied by QS minus here K except our, so K minus 1 minus L divided by 2, and they should react to each other optimally at the same time. So this should be system of equations. And here we see that we have two unknowns and two equations. So we can find actual quantities that will be produced and sold by each type of firm. That's fine. So what we can write? For example, we can write that N QS plus K QL, first part, plus K plus QS will be equal to 1 minus CS. And here, N QS plus K QL plus QL will be equal to 1 minus CL. I will write this. So, and here we see that these parts are the same. And how I can find quantity of small firm out of a quantity of large firm? I can say that to find quantity of small firm, it is quantity of large firm plus CL and minus CS. From here, quantity of small firm is quantity of large firm plus CL minus CS from here. And I take this and put into this or that, doesn't matter. What will we find? We find that N plus K plus 1 QS plus K plus 1 QS is equal to 1 minus CS minus K CS minus CL. And similarly, N plus K plus 1 quantity of large firm is equal to 1 minus CL minus N CL minus CS at the same time. Then, how to solve this? What we know? We know that now we find the interior solution. So these two quantities should be greater or equal than 0. Yes? So this always 0 and plus K plus 1 always 0. So for quantity for small firm to be greater or equal than 0, this part should be greater or equal than 0. Here also for interior solution. So from here we write that our equilibrium, Nash equilibrium, is what? Quantity for small optimal quantity is equal to 1 minus, no, write down like this, 1 divided by N plus K plus 1 multiplied by 1 minus CS minus K CS minus CL, and quantity for low is equal to 1 divided by N plus K plus 1 minus C low minus N C low minus CS. And this is true when the 1 minus CS greater or equal than K CS minus CL for such parameters, and 1 minus CL should be greater or equal than N CL minus CS. So this is one solution, interior, one Nash equilibrium. what should be in your answer? Nash equilibrium is the optimal set of strategies. Strategies for each firm here is to set quantities. So this is the answer for symmetric Nash equilibrium. What other Nash equilibrium we can find? How do you think? Can there be the situation when one type of firms produce nothing and other type of firms produce quantity greater than 0? Produce something. So, which type will produce nothing in such situation? Which type, small or large firms? Which type will produce nothing? I don't hear it.
Small firms
Small
will produce
firms.
nothing. Yes.
Small firms will produce nothing, yes, because they have higher costs, yes? So let's consider this situation, boundary situation. When quantity for small firm is 0 for each. So that's why quantity for low firm will be equal to optimal quantity. This how we can find. We will find it from best response for low firms, or for large firms, sorry. From best response. Let's see. I erased it, yes. So from best response, it will be 1 minus C large plus K minus 1 quantity of large firm divided by 2. So from here we can find this from best response for low firm. From here we will find the answer. Quantity for low firm will be here 2, here K minus 1. So it will be K plus 1, yes? 1 minus C large divided by K plus 1. So this is also Nash equilibrium. This equilibrium will be when these conditions are reversed. This is true if 1 minus Cs less than K Cs minus C low, 1 minus C low less than N C low minus Cs. No. It's when quantity for small should be equal to 0. Only this condition, I'm sorry, only this condition should be reversed. And quantity for large firms should be positive, so this condition should be true. Only this one. And 1 minus C0 greater or equal than N CL minus Cs. Only for small firm, this condition should be reversed. Then this quantity will be equal to 0 in equilibrium. So, the questions, please. So we have here two answers.
Можно вот у вас спросить, почему n плюс k плюс 1 это равно единице? Вот наверху. n плюс k плюс 1 равно нулю.
Больше нуля. Greater than 0.
Больше нуля. Все, понял.
Let's move on. In the next part, we have such situation. In the next part in B, all our large firms collude. So they are now, they act now as one big firm, one big large firm collude. And small firms also collude. So now we have like two big firms in the market. And then, as always, we should find Nash equilibrium when in such situations each firm sets its quantity. So let's consider, for example, large firms. Large firms set their quantities, but together they at the same time they decide how much each large firm will produce. It's their decision. Like they act like one big firm. Yes, when they collude. So large firms set Q1 large from Q1 large to Qk large to solve what? If it is now big large firm, they act like big large firm. They solve, they maximize, they maximize the sum of profits from all these large firms right now. So they maximize the sum from G is equal, from I is equal to 1 to K, and the sum of profits of all these firms. 1 minus sum from G equal to 1 to N, Gs minus this price minus G is equal to 1 to K, Qg large, let's write it minus CL minus marginal costs multiplied by quantity of each large firm. And this we should maximize at the same time by all quantities of these firms, by all quantities. But how we can rewrite it? This sum, we can put it here, yes, to sum quantities that are produced by all large firms. Let's rewrite. So here will be 1 minus sum Gs from G equal to 1 to N minus sum from G equal to 1 to K Qg L minus CL multiplied by the sum of quantities from E equal to 1 to K or E large. And this we should maximize. And you can see that when firms collude, it is the main thing is to maximize the sum of quantities, is to set the whole quantity, the whole amount that will be produced and sold by all these large firms, And it is the main idea, it is the main thing. So we can rename these sums. For example, let's say that sum of quantities of small firms, we will say that this is Q capital for small, and this Q capital for large. This also Q capital for large. And then when they set this big quantity for large firms, then they will, after that, they will decide how much each firm will produce. For example, they will produce identical amount, yes, same amount for each firm. So the main thing is to maximize this sum, to find out this big quantity that will be produced by all large firms that now collude. So let's write the words. Note that only aggregate quantities matter. Note that only aggregate quantities matter. And the same is true for all small firms, because they also collude. Same is true for small firms. And let's look at the Nash Equilibrium, where each firm produce the same amount in two groups. We look for a Nash Equilibrium where quantity that will be produced by each large firm is Q capital large divided by the number of large firms, K, and quantity that will be produced by each small firm is Q capital small divided by number of firms, by N. And how we can find very fast how we can find these big quantities. From where? What we can say? From point A. From point A. Let's see. When large firms collude and small firms collude, they act like two big firms in the market. Yes? Two big firms. So we can say that there are one small firm, one big small firm, and one big large firm. And that's all. So N will be equal to 1 and K will be equal to 1. And this how we can find very fast quantity for small firms and quantity for large firms. And that's all. That's why I did not erase this part. So from here, this is the answer. We use point A. Let's write down. Quantity for large and quantity for S are given in part A for K is equal to 1 and N is equal to 1. And that's all. And we can write the answer. So, quantity E, no. Quantity for large will be equal to here 1, 1. So 1/3. 1 minus here 1 minus 2 CL plus CS. Yes. And quantity for small, for big small, is 1/3. 1 minus 2 CS plus CL. And if we want to find quantity that will be produced by each firm, we should divide here by K, here by N, and that's all. That's right. It's optimal. So quantity optimal for each large is equal to 1, 3 divided by 3 K, 1 minus 2 CL plus CS. And here quantity optimal from for each small firm is 1 divided by 3N, 1 minus 2 CS plus CL. This is the answer. This is Nash Equilibrium. Interior. And let's say that we will have only here we write down only interior solution, but you can check also boundaries at home, right? So here, please, questions, guys. This is the main thing in this part, that we can take answers from part A, but say that if we have two big colluded firms, we can say that K is equal to 1 and N is equal to 1 and write down the answer, and so on. So then, what we can say in point C, part C. In part C, all firms in the market collude. So now they act as monopolists, yes? All firms collude. Now they act like one big firm. And we should find total sales. So this one big firm right now, it's monopoly. She will maximize its profit, its total profit from all firms. So the profit will be for this big firm is price 1 minus quantity for low minus quantity for small. This price multiplied by total sales quantity from small plus quantity from large minus costs, this revenue from all firms minus costs. Costs from small firms, CS multiplied by total sales of small firms minus C large multiplied by quantity from large firms. And this we should maximize by quantities from small and large firms. So, if it is now very, very big firm, and this big firm has technologies and resources from small and large firms at the same time, what we can say about quantities produced in small and large firms? The main idea. Understand? If we have all technologies, we will use best technology. Yes. So what firms will produce and what firms will not produce? Please answer. I don't hear you.
Because we don't know. Maybe on the large firm.
Sure, because we know that marginal costs in large firms less than marginal costs in small firms, yes? So why do we need to produce in small firms if we have better technology, if we can save money, yes? So we can say that from here, I will write here, as marginal cost for large firms less than marginal cost for small firms, we will use the best technology, we will save money. We will produce only in large firms. So total production in small firms will be equal to 0, yes? Because we use best technology. Use best available technology. To have minimal costs. This is the main idea of this part. Yes? Is it clear? Guys, please. So.
For small firms?
Hmm?
I mean, is it profitable for small firms to produce nothing?
It is now one big firm. All firms collude, and they will have very big one profit, one big profit. And then how they divide this profit? Yes, how they divide this profit? It's not our task. It's their business how to divide this profit. But we know that to maximize this big profit, we should use technology we should use best technology. And then that's why we will have the maximum profit. So only large firms will produce something. And then they will have one big profit and then divide it, but we don't know how. It's not our question. So, if quantity for small firms is equal to 0, so they should maximize 1 minus 4L divided by 4L minus CL for L. First derivative, 1 minus 2L minus CL equal to 0 for entire solution. And this is true, it's entire. From here, optimal total production for large firms is equal to 1 minus CL divided by 2. And it's greater than 0. Okay, we know this. Yes, because 1 is bigger than CL. And each small firm produce 0. And this is optimal when all firms collude. Our answer, total sales, this one. Yes. These are total sales of such monopoly, such big firm. Please ask questions. This is the end of problem 1. I begin to erase. So the main idea under Cournot competition is that when firms act independently and simultaneously, they at the same time they maximize their profits, and they can control only their quantities, not quantities of their opponents, of other firms. So they take quantities of other firms as given. So these quantities of other firms are constants for our firm when we maximize her profit, and that's all. And then we find the best responses, and then we find the situation when these best responses intersect, and when nobody wants to deviate. And from here we find Nash Equilibrium. It's the set of optimal quantities, strategies, yes? Now, strategy is to set quantity. So we write down Nash Equilibrium, that's all. In point B, there were Cournot Nash Equilibrium, standard Cournot Nash Equilibrium for 2 firms. Like when small and big collude, and they act like 2 big firms. Here, it's monopoly answer. It's the answer for monopoly. How much to produce? Questions? Okay. Right now, we'll move on, and we consider the second problem. In the second problem, we see that here is Bertrand competition, what we see? Market demand is equal to 1 minus price. This is not inverse, but demand. Yes. We have two firms, 1 and 2. Marginal cost for first firm is are less than marginal cost for the second firm and less than 1. And we should find Nash Equilibrium when our two firms set not quantities but prices. When they set prices independently and at the same time. Set prices. And one more thing. In your task, it is written that if our consumer is indifferent from which store to buy, it will buy from, she will buy from the first supermarket, from first firm. If consumer is indifferent, then buys from firm 1. This matters in our task. So this is our task. And my first question for you, what we should write down in the answer? We should find Nash Equilibrium. What we should write down in the answer? The set of what? The set of optimal strategies. Optimal strategies right now are what?
Price 2 should be less than price 1? No?
I don't know. But you're right that in answer, we should write down prices. Yes? So, and you now can tell me the right answer. What will be the price for the first firm, optimal price, and the price for the second firm, optimal? You can tell me the answer right now. You can tell me the solution to this problem. What do you think? What prices they will set in equilibrium?
If it is equilibrium, the prices should be equal, no?
Yes, prices will be equal in equilibrium, yes. And equal to what? We don't have many options, yes? They will be equal to C1 or C2 or monopoly price, yes? What will we choose? Why? It's not profitable or so profitable for the first firm. Why? Because if the price is equal to C1, yes, first firm will have all demand, but her profit will be 0 because the price is equal to marginal cost.
Price should be equal to 1? No.
So, let's see. Guys, I'm sorry. We have problems with connection, not internet connection, but problem with Zoom, with the program. Do you see me and hear me? Yes?
Yes.
Okay, let's continue. Let's continue. So, we have this Nash equilibrium. Why? Let's discuss. We should use the definition of Nash equilibrium. It's the set of strategies when nobody wants to deviate. Yes, so we should consider different deviations and then check that all deviations are not profitable for our firms. That's all. This is how we will prove that this situation is actually Nash equilibrium. Let's see. Now, first of all, we should discuss it. Why actually this? For such prices, profit for the first firm will be how much? Quantity. 1 minus price, 1 minus C2. Yes, this is quantity that is sold by the first firm. Why? All demand is taken by the first firm. Because if consumer is indifferent, then buys from firm 1. Yes? So our first firm will have all market demand multiplied by price minus costs. Price is C2 minus costs C1. This is price. This is marginal costs of the first firm. So, and this profit, what we know that C2 is greater than C1, 1 minus C2 also greater than 0, so this profit will be positive for the first firm. Profit for the second firm. If consumer is indifferent, then buys from firm 1. So the second firm will have no consumers in her shops, in her stores. So her profit will be 0.
Mhm.
Yes?
Yes.
So, and now we should consider deviations. What means deviation? To set not this price, but higher or lower. And we will consider all these situations. First, let's consider a second firm. If price of the second firm if she deviates, for example, upwards, if she increases her price higher than optimal. What profit she will get? Profit of the second, first of all, the demand for her products. When first firm does not deviate and second firm set price P2 will be equal to how much? If our second firm increases the price, nobody will come. Yes, nobody will come, so the demand for her product will be equal to 0. So the profit of the second firm, when first firm does not deviate and second firm deviates upwards, is also equal to 0. So with such deviation, our second firm cannot increase her profit. It will be the same. Yes? So it's not profitable deviation. She will not do it. No profitable deviation. Then maybe our second firm should make the price lower. If price of the second firm is lower than price in equilibrium, the demand for her products
will be negative.
Will be what?
Will be negative.
Why negative? Demand, sales. How many people will come?
Yeah, okay.
All?
1 minus people, no?
Yes. All will come to this actual shop. Yes, because here now prices are lower than in the first shop. So the demand will be 1 minus price of this second firm. And profit in such situation, when first firm does not deviate and second firm deviates downwards, is equal to total sales 1 minus P2 multiplied by price minus costs minus C2. And this bracket is less than 0. Yes, because the price is now lower than marginal costs of the second firm. Because price in equilibrium is equal to C2. And we know that now P2 is less than C2. Less than 0. So the profit will be negative. And in equilibrium, profit is 0. We don't want negative profit. Yes, so it is also now not profitable deviation. Next, so our conclusion is that the second firm does not want to deviate. Maybe the first firm wants to deviate. Let's see. Maybe first firm wants to deviate upwards. If price is higher than price in optimum for her. Then, if she will set higher price, nobody will come. Yes, because they will buy from the second firm. So the demand for her products when second firm does not deviate is equal to 0, and profit in such situation for the first firm will be equal to 0, and it is less than positive profit in equilibrium. So our first firm will not want to deviate upwards. No profitable deviation. Maybe she will deviate downwards. Make her price lower. Let's see. If price of the first firm will be lower than equilibrium price. So the demand will be the same. The demand everybody will come to this first firm, yes? Will be equal to 1 minus P1, and profit will be equal to total sales 1 minus P1 multiplied by price minus costs of the first firm. And this profit is less than profit in equilibrium, yes? Because 1 minus C2 is less than 1 minus P1. No, this is greater. Yes, let's compare. Let's compare. And C2 minus C1 greater than P1 minus C1. Because profit less than 1 minus C2, C2 minus C1. So here also no profitable deviation. So we made the conclusion that such prices are optimal. They construct the Nash equilibrium in this market because nobody wants to deviate. We proved it. We considered all deviations and found that all deviations for each firm are not profitable. So they will stay with such prices. That's all. Please ask questions. So you see that we solved it not as the first problem, yes? We wrote down the answer first and then proved that this is the right answer. Is it clear? Please tell me that it's clear. It's not very hard task. Guys?
Yes.
Yes? Yes, okay. So, now, one more thing. In your task, you have the assumption that 1 plus C1 divided by 2 is greater than C2. Why we need this condition for such situation to be Nash equilibrium? 1 plus C1 divided by 2 is the monopoly price for our first firm. If she acts as monopolist in the market. If everybody buys from her, yes. And why we need this condition? For example, this is the profit for the first firm. Here, price. C2, C1, C2, and we see that monopoly price, 1 plus C1 divided by 2. What means monopoly price? Monopoly price gives us maximum profit. Yes, if we act like monopolist, if everybody comes to us. Yes? And profit will be equal to 0 if price is equal to C1. Then here C2 and maximum in monopoly case. Maximum profit. So this condition is given for us not to deviate for our first firm, not to deviate downwards. If we will have the opposite sign, what our firm wants to do, first firm, if opposite sign, it will be C1 monopoly price, 1 plus C1 divided by 2. Here is C2. You see, this is maximum profit. And in such situation, if the sign is opposite, In such situation, our first firm wants to deviate downwards to increase her profit. You see? And for not having such deviation, we need this condition. Why 1 plus C1 divided by 2? If monopoly, if first firm is monopoly, her profit is what? 1 minus P1 is quantity, total sales multiplied by P1 minus C1. And when we maximize it by choosing the price, first derivative, 1 minus 2P1 plus C1 equal to 0. And from here, monopoly price is equal to 1 plus C1 divided by 2. So this price gives us maximal profit. And for us, we do not want to deviate if we have such condition. That's why it is given in the task. So, okay. So now, actually, I don't have time to record the third problem from the previous class. So I will send you solutions that are written by my hand. Okay, I'll send to everybody. And I will not report how to solve it because it's not simple, but we did 2 problems, and if you understood how to solve 2 problems from the previous class, you can solve a third problem by yourself, but I will send you solutions. So that's all. Please, if you have questions, please ask. You have 2 minutes to answer. If no, so thank you. Have a nice week. And,
Should we found
I'm
solution 3 on Dropbox? Should we found solution 3 on Dropbox?
No, I will send solutions to your emails, to your group email. You have this foreigners, you know, for your group. Yes, and
Okay.
I will send solutions to all my groups, to mails, to group mails, to all my groups. Okay.
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 So thank you.